Hello everyone, myself Varun from Sri Venkateswara College of Engineering, studying in Chevrolet section. Today's topic is Markov analysis. Introduction to Markov analysis. Markov analysis is a statistical technique used to model systems that transition between states over time. It is based on the concept of Markov process, which assume the future states depend only on the current state, not on past states. This property is known as Markov property, and is fundamental in application like theory and economics. Key concepts of Markov change. A Markov chain is represented by a set of states and transition matrix that describes the probabilities of moving between these states. The transition matrix is square with its row summing to 1, indicating the total probability disturb, disruption for each state. Markov chains can be classified as discrete discrete time or continuous time based on the nature of the state transitions. Transition matrix are critical in determining the behavior of Markov chains over time. Each element in the matrix represents the probability of translating from one state to another. The matrix can be raised to a power to calculate the probabilities of state transitions over multiple steps. Stationary distribution. A stationary distribution is a probability distribution that remains unchanged as the Markov change transition between states and states. It is found by solving equation pi p is equals to pi, where pi is the stationary distribution and p is the transition matrix. The existence of unique stationary distribution is guaranteed for Markov chains. Types of Markov chains. Markov chains can be categorized as absorbing, regular, or ergodic based on this structure and behavior. Absorbing chains have at least one absorbing state that once entered cannot be left. Regular chains have a transition matrix that eventually allows all states to communicate, leading to convergence to a stationary distribution. Application of Markov analysis. Markov analysis is widely used in fields like economic, genetics, and computer science for predictive modeling. It helps in decision-making process such as predicting customer behavior in marketing. In finance, Markov models are employed for option piercing and risk assessment. Markov decision process. Extend Markov chains by incorporating actions and rewards into the model. An MDP consists of states, action, transition, probabilities, and rewards, allowing for optimal decision making in uncertain environments. Solution to MDPs often involve dynamic programming techniques such as value and policy iteration. Limitations of Markov analysis. One limitation of Markov analysis is the assumption of the Markov property, which may not hold in all real world. The analysis can become computational intensive for large state space, requiring simplification. Additionally, the model may simplify complex systems by neglecting historical influences or external factors. Markov analytics produce valuable into system characterized by probabilities transition between states. Understanding the underlying mathematics and properties of Markov chains allow for effective modeling and prediction. The versatilities of Markov analysis make it capable across numerous fields, enhancing decision-making process. Future directions. Future research in Markov analysis may focus on hybrid models that incorporates machine learning techniques for improved prediction. There is growing interest in exploring the application of Markov process in complex systems such as social networks and biological systems. Advancements in computational power will likely facilitate the analysis of larger and more Markov models, their applicability. Thank you.